Imagine a world where lakes are not made of water, but methane and ethane. This is not science fiction, but reality on Saturn's moon, Titan. On this icy celestial body, lakes composed of these intriguing elements behave in ways strikingly similar to our own earthly oceans, despite their starkly different composition. Join us as we dive into the cosmic wonder of Earth's oceans versus Titan's lakes. Despite being over 1 billion kilometers away from each other, Earth's oceans and Titan's lakes share some striking similarities. Now you might be thinking, how can that be? Especially when you consider that Titan's lakes are filled with methane, ethane, and nitrogen, while Earth's oceans are primarily composed of water, or H2O. Yet, these celestial bodies of liquid, though vastly different in their composition and the temperatures they endure, operate under the same fundamental principles. What are these principles, you ask? Well, they're all about how liquids behave and interact with their environments. For instance, both Earth's oceans and Titan's lakes stratify. On Earth, the stratification happens primarily due to temperature differences, with warmer water rising to the top and colder water sinking. On Titan, however, it's a bit more complex. The lakes stratify based on the density differences between methane, ethane, and nitrogen. The methane-nitrogen interactions lead to ethane-enriched layers floating on top of methane-rich layers. Another shared characteristic is the process of overturning. Just as Earth's oceans can overturn, causing nutrient-rich water from the depths to rise to the surface, Titan's lakes can also overturn. The methane and nitrogen in the lakes interact, causing eruptions that bring ethane-enriched layers to the surface. It's fascinating to think that despite the stark differences in their chemical makeup and temperatures, the lakes on Titan and the oceans on Earth exhibit similar behaviors. These bodies of liquid, one as familiar as our own backyard, and the other 1 billion kilometers away on a moon of Saturn, are both governed by the same universal principles. This goes to show that while we may look up at the cosmos and see an alien world, there are fundamental rules that apply universally. From the stratification of liquids to the process of overturning, the rules that govern our oceans also apply to the frigid lakes on Titan. These similarities are not just fascinating, but they also tell us about the universal rules that govern the behavior of liquids across the cosmos. While the similarities are compelling, the differences between Earth's oceans and Titan's lakes are equally fascinating. Starting with the most obvious, let's talk about composition. Earth's oceans are brimming with water, the lifeblood of our planet. But on Titan, Saturn's largest moon, the lakes are filled with a heady cocktail of methane, ethane, and nitrogen. This isn't just a minor detail, it fundamentally changes the behavior of these extraterrestrial bodies of liquid. One of the most intriguing differences lies in how these lakes stratify. Here on Earth, the layers in our oceans are determined by temperature, with warmer water rising to the top. But on Titan, the cold doesn't play the same role. Instead, the stratification of Titan's lakes is driven by density. The key players here are the chemical interactions between the lake's contents and Titan's atmosphere. The result? A fascinating phenomenon where methane-nitrogen interactions lead to ethane-enriched layers floating atop methane-rich layers. This process, known as density-driven stratification, can even cause Titan's lakes to overturn and erupt, a spectacle we're unlikely to see in our terrestrial oceans. And while Titan's frigid temperatures might make you think these lakes are static, they're anything but. Despite the cold, these lakes are dynamic, constantly evolving and changing. They're not just alien bodies of liquid, they're active systems that draw comparisons to Earth in the way they behave. But it's not just about the similarities, it's also about the differences. The unique composition and behavior of Titan's lakes offer a new perspective, a fresh lens through which to view and understand the universe. They challenge our definitions and force us to rethink our understanding of what a lake, an ocean, or even a planet can be. These differences not only add to the intrigue of Titan's lakes, but also open up new avenues of scientific exploration. Beyond their basic properties, Titan's lakes hold deeper mysteries that scientists are only beginning to uncover. In a world where methane and ethane take the place of water, the rules we're accustomed to on Earth don't always apply. Titan's lakes, unlike our familiar bodies of water, stratify not based on temperature, but on density. This curious behavior arises from the chemical interactions between the lake substances and Titan's dense nitrogen-rich atmosphere. Researchers from the Planetary Science Institute have uncovered a fascinating phenomenon. They found that Titan's lakes can overturn and erupt, a spectacle that would be quite a sight on this distant moon. But what causes this to happen? The answer lies in the unique properties of the lake constituents, methane, ethane, and nitrogen. Methane and nitrogen, when they mingle in the lakes, undergo a series of interactions that result in ethane-enriched layers. These layers, surprisingly, float atop the methane-rich layers, creating a strange and intriguing stratification. This is a stark contrast to Earth's lakes, where warmer, less dense water floats atop colder, denser water. On Titan, it's not the temperature, but the chemical makeup that dictates the layering. Now, imagine a lake on Titan overturning. The denser methane-rich layer suddenly surges upward, displacing the lighter ethane-enriched layer. This results in a spectacular eruption, a dance of liquid hydrocarbons that is as alien as it is fascinating. These mysteries make Titan's lakes a compelling subject of study for scientists trying to understand the diverse processes that shape our universe. With each new discovery, we realize that while Titan might be a frigid, distant moon, its dynamic lakes echo the vitality of Earth's own bodies of water. It's a testament to the incredible diversity of celestial bodies, and a reminder that the cosmos is full of surprises waiting for us to uncover. You might be wondering, why does it matter what happens on a moon more than 1 billion kilometers away? Well, the answer is a lot more significant than you might think. The study of Titan's lakes doesn't just broaden our understanding of this distant moon, but it also provides us with a unique perspective on our own home planet. The same laws of physics that govern the stratification of Titan's lakes are at work right here on Earth. By observing and understanding the behavior of liquids in different environments, we can gain insights into our own oceans. This knowledge can help us predict and respond to changes in our climate, from rising sea levels to changing weather patterns. What's more, these studies offer an exciting glimpse into the possibilities of life beyond our planet. The presence of methane and ethane in Titan's lakes raises the question, could these substances support some form of life? It's a tantalizing thought, and while we can't say for sure, the possibility alone is enough to fuel our curiosity and our continued exploration of the cosmos. In a way, studying Titan's lakes is like looking into a mirror that reflects not just what is, but what could be. It's a reminder that we are part of a larger universe filled with extraordinary phenomena and potential life. The exploration of other celestial bodies like Titan pushes the boundaries of our knowledge, challenging our understanding of what it means to exist in this vast universe. In essence, every new discovery on Titan, every layer of ethane and methane we uncover, every eruption we observe, is a piece of a larger cosmic puzzle. Each piece brings us closer to a better understanding of our own planet, the potential for life beyond Earth, and the fundamental workings of the universe. In the grand scheme of things, understanding the workings of Titan's lakes brings us one step closer to comprehending the complexity and wonder of our cosmos. So, let's keep exploring, keep questioning, and keep marveling at the wonders of our universe. The universe is a grand stage, and we're all part of this exciting cosmic play. From our blue oceans to Titan's methane lakes, the universe is full of wonders waiting to be discovered. We've delved into the surprising similarities between these two bodies of liquid, finding common ground in their stratification processes. Yet, the intrigue lies in their differences, with Titan's lakes overturning and erupting due to methane-nitrogen interactions, a phenomenon unseen on our home planet. The mysteries of Titan's lakes continue to captivate us as we draw comparisons to Earth's oceans and ponder over the simple rules and processes controlling these cosmic wonders. What this means for us is a step closer to understanding the universe and our place within it. Don't forget to like, subscribe, and share your thoughts on these cosmic wonders in the comments below.